Okay, so we've already talked about solving for the present value, or sorry, the future value of a lump sum. We've talked about solving for the present value of a lump sum, and those are, pretty much the main calculations in accounting the vast majority of the time. Again, with the present value being the predominant one. But now we're going to kind of get into solving for some of the other factors. We're going to start with periods, and we're going to do interest rate and some of these other things. And so, so this next section is kind of get a little more, again, blocking and tackling using the equations, using the tables, and using your time value of money calculator. Now, I will say, generally speaking, I think solving for periods and for solving for the interest rate is much easier when you use your financial calculator. So if I were you, I would get familiar with that, so that when the test comes and even beyond this class, that you're prepared to use your financial calculator, because I think it's the most effective tool to have. All right, so let's kind of talk in general. So again, we've solved for these other things, and now we're moving on to solve for n. And so we can use those same mechanisms. We can use equations, we can use the table, we can use the calculator in order to solve for each of these things. Now, on the test, admittedly, kind of the calculator is where most of this is going to be leaning toward. But you could also potentially use, an equation, or use the tables if you wanted to. But we're going to show you how to do all three. All right, so again, back to our core example, because we know the answer, but we want to make sure we understand it. So, they currently has $10,000. They can earn 10%. And now, instead of giving you the n, we're going to give you the future value, saying, okay, well, at what point will they have $13,310? Now, we know the answer is 3, but let's kind of walk through how we can solve that using an equation. Now, I would say very little more algebra. So there is a little more algebra involved in this as far as using the equation, but we're going to kind of start with our future value equation. And so we know that from the start, future value equals present value 1 plus I to the nth. And again, we're trying to solve for n. And so how do we do that? Again, the kind of thinking about our example here, again, we have all the information that we have except for n. And then, we can kind of take the 10,000, divide, both sides by 10,000, which leaves, 1.33 on the side. And then we know, maybe you remember this from algebra, but if I have an exponent and I want to solve for it, I can take the natural log of both sides, because if I take the natural log of the left-hand side and the right-hand side, of course, that remains equal. And then I just take the right-hand side, and if I kind of take, if I kind of write it out here, if I have, I'm not great at this, but that does equal n times line x. I'm not great at this, sorry. Those two things, so if that's the nth power, you can move the n out in front, and those are the same thing. And that's essentially what we're doing right here, is there's an interim step where we're kind of saying natural log of 1.3310 equals natural log of 1.10 to the nth. And then we just move that n over. And if we kind of do it like this, if we kind of think about it that way, we can move the n out in front. All right, and so that's essentially what we do. And then we just divide both sides by basically the line natural log to the x, which would be 1.1 in this case. But again, this algebra is not what we're going to be testing you on. So I just want to be very clear. We are not testing on this algebra. I wanted you to see where the algebra came from. And of course, when we solve that, then we do get n equals 3. And so if we kind of want to take the general form of the equation, yeah, it's painful, but this is how I could solve for n using an equation. You are not required to know this equation on a test. So you do not need to know it for a test. But I wanted you to see where the information came from. And so when we look at this, if I wanted to use an equation to solve for n, it is a little bit complicated, but you can do it. And here's the equation that you would use. Now, the tables approach is not too bad. It's kind of similar to using what we were already kind of talking about, but really it's still bidding off that basic equation. And so, basically, and again, this is kind of the key, is you have to isolate the calculation of the factor. You somehow have to figure out, okay, what is the relevant factor? And so when we kind of do this math, you can see that this, if I'm looking at, let's say, the present value factor table, we're looking at the present value factor table. When I do that, I can see that, basically on the left-hand side, I've got PV over FV. And on the right-hand side, this is the factor, right? So this piece of information right here, that is how we calculate the factor from the table. And we can see that that factor is calculated as the ratio of the present value to the future value. And so in this particular case, the present value is 10,000. The future value is 13,310. We can solve that, and that gives us a factor of 0.7513. And so then what we do is we take that factor and we look in the table and we try to find sort of where that intersection is. Now, in this case, we know that the interest rate is 10%. And so we work our way down until we find the factor. And so we can see that the factor that we solve for corresponds to 3. And so we know that the n is 3. And again, we're using the tables to solve for the n. And hopefully you're already sensing that the equation approach is not real easy. Tables approach is easier, but still not real easy. And so it can become a little complicated. But let's do the tables approach one more time. So our company has set aside $6,500 in a 7% annually compounding interest account. The company needs $9,755 to purchase a needed pieces of equipment. How many years will it take them to have the necessary funds? So we're solving for n. Again, looking at our factor table, the first thing we have to do is calculate the factor. And to calculate that factor, again, we take the ratio of the PV to the FE. And again, this is using the present value of a lump sum factor table. We can see that the factor is 0.6663. And now we're going to be focusing on, okay, what interest rate column should we be using? And we should be using the 7% column. So we're looking at the 7% column, looking for a factor of 0.6663. So again, the 7% column corresponds to this n equals 6 row, as far as where the intersection equals the factor that we are looking for. Again, so we can use the table in order to do this. Now, there's a limitation in that if, let's say, the present value and future value ratio doesn't land exactly on one of these factors, it does become a little complicated when you might have an n that's, let's say 5.42 or something like that. So it becomes a little more complicated in that case. All right, so the time value of money approach. Much like we've done, whenever we use the time value of money approach, we're saying, okay, what are we solving for? And again, whenever we're talking about how long will it take or how many periods, we're focused on trying to solve for our n. So we are trying to solve for our n. And again, we fill in the rest of the information. The I/Y is 10. The present value is negative 10,000, positive 13,310 in the future. Again, so we put in $10,000, we take out $13,310. How long will it take to do that? And the answer is, of course, we know is 3. Remember, to solve for the 3, it's compute, then n. So you compute the n, which is where we get our 3. In our second example, try to do this on your own if you can. Again, you can pause and then kind of push forward. But looking at this, again, hopefully just pause real quick and then solve the rest of it. But we do have our I/Y is 7%. The PV is negative 6,500. The FV is positive. The key here is that these just have to be opposite signs. So if the present value is negative, the future value has to be positive and vice versa. And so, in this case, when I say set aside, the idea is I'm taking money and I'm putting it into account. So it's kind of going out. And then how much can I take out of that account? How long will it take me before I can withdraw $9,755? And so that's why I did it with those signs. If you'd done the opposite, it would not be wrong. But when I solve, of course, we know that we're going to get 6, and that is what we get. All right, so that's solving for the number of periods. Again, in my opinion, using the calculator is by far the easiest, but I wanted to show you that you can use an equation, and you can also use the tables if you'd like. All right, so the next thing we're going to solve for is the interest rate. And so again, another piece of missing information could at some point be the interest rate. And so, if that were the case, then, it's a little more challenging to use equations and tables. You can do it. And I do think it's still easier to use the time value of money calculator. But again, we're going to kind of show you each piece. And so, again, back to our example, they have $10,000. They invest the money for 3 years. At the end of 3 years, they get $13,310. So, what return did they get? And we talk about return, we mean annual return. What was their annual or periodic return? And so in looking at this, again, we can go through our equations, more algebra here. Again, we're going to start with our future value equation, and we're trying to isolate how do we get to the I. And so, thinking about our example, we have 13,310. That's the future value. The present value is 10,000. Of course, we don't know the I, but we do know the N. So when I isolate things, I'm just dividing both sides by 10,000. And then from there, I take the cube root of both sides to isolate the I. Then I subtract 1. And if I do that, if I take the cube root of 1.3310, I get 1.1. 1.1 minus 1 gives me 10%. So that is my periodic interest rate. I can take that and make it into a general form equation. This is not an equation that you need to know for the test, but I wanted you to understand how we can do this using an equation. And this is how we would do it. So it's the ratio of the future value to the present value to the nth root minus 1. So that is the general form equation for how to solve for an interest rate using time value of money. Again, not easy, but it is the equation that you would need to use. With the tables, kind of a similar challenge in that, you got to get that factored, you got to figure out the intersection. And again, we're going to use that same example. So we know that the factor was 0.7513. We already solved for that last time. It was the ratio of the present value to the future value, 0.7513. And in this case, we don't know the N, but we do know the I/Y was 10%. And so again, we look for that intersection. So we look at, we know the N was 3, I think, in this example. We know the N is 3, so I kind of misstated there. So we don't know the interest rate, but we know the N. And so what we would do is if we know the N is 3, we would look right here, and then we'd look for that factor. We'd move all the way across and then say, oh, there's that factor. And that means we know that the interest rate is 10%. Again, that's sort of the way you'd use the table. Another example that we can try on your own. So go ahead and try this. A company has a client who agreed to pay $3,666 in 8 years. They're indifferent between that payment or receiving $2,300 today. So what is the interest rate? In other words, what makes those two amounts equivalent in the mind of 49er company? And so again, you can go pause it here, figure out, but again, the key is understanding that ratio, using that ratio to get to a factor, finding that factor on the table. So that's the process. So pause it here, and then we'll pick it up. All right, so the ratio of present value, again, we're going to be using the present value factor table. And so the present value to future value, that ratio is 0.6274. And so that is the factor that we're looking for. And we're looking for that factor in the 8-year row. So that's where we're focused on. And so on the next page, we can look at the 8-year, and we're looking for that, sorry, I forgot the number, 6274. So we can see in that row, we can find that factor, and we can see that that factor corresponds to 6%. And so we know that the interest rate that they're using is a 6% interest rate. And then finally, using our calculator, the key here is that we're solving for the I/Y. We're putting the information in. We know the 3, we know the present value and the future value, and then we compute I/Y. Again, I don't want to belabor this example because we've seen it a gazillion times. But essentially what you do is you fill in the other information and you solve for the I/Y. And then the other example that we just did, again, similarly, we know that the N is 8. We use a negative 2,300 and a positive 3,666 because again, I'm going to get paid $366. Again, the signs don't matter as long as they're opposite. If they're opposite, if they aren't, if you, let's say you did negative here and negative there, it actually will give you an error. And so if you get an error, it's probably that your signs were messed up. That's more than likely what happened. But when we do that, again, we put in all the information in the other 4 buttons, and then we solve for the I/Y of 6. All right, so that's it for this lecture. Next time we're going to be picking up with annuities, and so that's where it's going to get a little more interesting, a little more complicated in terms of algebra and things like that, but we'll tackle it as we get there. All right, I think that's it. Yeah, that's it.